Okay, so in this podcast, we're going to be looking at multiplying and dividing of surds, and also special products of surds. So similarly to how we would expand algebra, we're going to be doing it with surds. When we multiply two surds together, we multiply whatever's outside. We'll call it our coefficient. So that's the thing that's out the front. And then we multiply whatever's underneath by whatever's underneath. So like we did before, when we multiply whatever's under the radical by whatever's under the radical, we do the same here. When we divide, just like fractions, we divide whatever's outside, and then outside the square root, and then we divide whatever's inside the square root. You'll notice here it says C can't equal 0 because we can't divide by 0, and that's assuming also that D can't equal 0 because we can't divide by 0 in a radical either. As usual, we should always give the answer in simplest form, so that means once you've multiplied it out, you then need to simplify it if you can. Okay, so when we multiply these two surds together, we multiply outside by outside, so 5 by 3, and then inside by inside, 7 by 2. We know that 5 3s are 15, 7 2s are 14. There's nothing that goes into 14 that's a perfect square, so that's our surd in simplest form. Here we are going to divide 15 on 3, root 77 on 7. 15 divided by 3 we know is 5. Under the square root we've got 77 divided by 7, which we know is 11. And there's nothing that goes into 11 that's square rootable. No perfect squares are factors of 11. Okay, here I've got 5 times 7. I'm just going to do it the quick way. So 35, root 60. Okay, now I've multiplied outside by outside, inside by inside, but now I've got to say, okay, is there anything that goes into 60 that is square rootable? And I know that 60 is 4 times 15. So we can say 35 times root 4 times 15. We know that the square root of 4 is 2, so bring it out the front and multiply it. 70 root 15. And no perfect squares go into 15 except for 1, but we know that that's pointless. Okay, I've got 18 on 3, which we know is 6. Then I've got 10 on 5. 10 divided by 5 is 2, so 6 root 2. We can't do anything else with that because you can't square root 2, so that's it, 6 root 2. Here I've got 2 root 7 squared. Now a lot of people will forget about squaring the 2, but you actually have to square the 2. So it's the same as 2 squared root 7 squared. If I square 2, I get 4. If I square root 7, I just get 7. So I get 4 times 7, which is 28. Same here, I've got a cube now instead of a square. So I've got 2 cubed and then root 3 cubed. Now in this case here, 2 cubed we know is 8. We know that root 3 cubed is root 3 times root 3 times root 3. We know that root 3 times root 3 is just 3, so I get 8 times 3. That's those two together. And then I'm left with a root 3 at the end. This also ends up being 8 times 3, which is 24 root 3. So in this case here, because it was to the power of 3, I just multiplied it out 3 times. And we know that root 3 times root 3 is just 3. And I multiplied 8 by 3 to get 24. And we've got square root 3. It's a little bit harder, but probably the easiest way is just to expand it out, like we have here, and then simplify it. Okay, the distributive law. So when we multiply algebra, if I had a x plus b, we know that we multiply the a by the x and then the a by the b. We do exactly the same thing with surds. Remember, outside by outside, so this is basically 6 root 1 because there's no square root there. So On the outside, I get 12. On the inside, I get root 5 times root 1, which is root 5. Then I multiply 2 by 3, and I get 6. And then I get root 5 times root 5, which is root 25. If you can do it, you can also just replace that with 5, because you know root 5 times root 5 is just 5. Then we're going to simplify this. So from here, 12 root 5 plus 6 times 5 is 30. That's it, simplified. We can't add any of these together. We could take out a common factor of 6 if we wanted to. It's probably not necessary, but if we wanted to, we know that 6 goes into both of them, so I'd have 2 root 5 plus 5. The reason I would say that, because if there was something on the bottom and you needed to simplify it, you could take out a factor and then simplify it with the bottom if it was possible. But you don't have to do it. It's just that if you needed to simplify it, it'd be a good idea. Okay, so negative 4 root 3 times root 6. So I'm going to have negative 4 times 1, negative 4, root 3 times root 6, which is root 18, plus, because I've got negative 4 times 2, plus 8 root 9. Now I know this can be simplified to be negative 4, 9 times 2, and then plus 8 times the square root of 9 is 3, so 24. Here, the square root of 9 is 3, so we bring it outside and multiply. So I get negative 12 root 2 plus 24. And just like we did before, if we wanted to, we could take out 12 as a common factor. I'm going to put this first, so 2 minus root 2. So I took a 12 out of there and got a 2. I took a 12 out of there and got negative root 2. And I just change the order of it so it looks a bit nicer. Instead of having a negative at the front, I've got 2 minus root 2 instead of minus root 2 plus 2. Just looks a bit neater. Okay, binomial products. With Surds, we do exactly the same thing as we do with algebra. So I use FOIL first, outside, inside, last. So in this case here, I multiply 2 root 3 by 4 root 3. So 2 times 4 is 8. I'm going to say root 9. I know it's 3, but it's up to you whether or not you just want to simplify it straight away. Then outside, so 2 root 3 times 2 is going to be 4, because 2 times 2 is 4, and then I've got root 3 under the square root sign. Negative 1 times 4 root 3 is negative 4 root 3. Then lastly, I've got negative 1 times 2, which is negative 2. Here, 8 times 3, because root 9 is 3, is 24. I've got plus 4 root 3 and minus 4 root 3. They cancel each other out. And then I've got minus 2, which is 22. So this one, the surd actually disappeared when we multiplied it out. Okay, B, let's multiply the first two things together. So I'm going to have 15 root 6, so outside, outside, inside, inside. Then I'm going to have 3 root 2 times negative root 2. That's going to be negative 3 root 4, because 2 times 2 is 4. Then I'm going to have these two multiplied together inside, so 20 minus 20 root 9. Then I'm going to have the last two terms together, so I'm going to have plus, because minus 4 times minus 1. And then underneath the square root, I'm going to have root 3 times root 2, which is root 6. So it's going to be plus 4 root 6. Okay, then we simplify. I've got 15 root 6 plus 4 root 6, which is 19 root 6. I've got minus 3 times 2, because the square root of 4 is 2, so minus 6. And then I've got minus 20 times 3, because the square root of 9 is 3. So I get minus 60. So here we end up with 19 root 6. 19 root 6 minus 66. And we just leave it like that. We can't do anything else. You can't add them together because there's no like surds. So that's it simplified. Okay, so here exactly the same thing. First term by first term gives me root 10. outside gives me minus root 14. Inside gives me plus root 15. And then last gives me negative root 21. Now, people will try and add these together, but we can't do anything with it. We don't have any like surds, and we can't simplify them all. There's nothing that goes into 10 that's square rootable, no factors. 14, 15, and 21. So that's it. You can't simplify it any further. Here, if you think about this in terms of algebra, I get A plus B, A minus B, because these terms are exactly the same. So this is a difference of two squares. Now let's have a look at what happens when there's a surd and a difference of two squares. So root 2 times root 2 is root 4. Then I'm going to get minus root 6, then plus root 6, and then I'm going to have root 3 times negative root 3, which is negative root 9. The plus and minus root 6 cancel each other out. I end up with a 2, because the square root of 4 is 2, minus the square root of 9, which is 3. I end up with negative 1. So when we do a difference of two squares with surds, do we always get rid of the surds? Maybe we'll look at that later on. Possibly. Could be used as a little trick, I think, later on. Okay, so here's a review. When we multiply outside by outside, inside by inside. When we divide, outside divided by outside, inside divided by inside. Of course, you can't divide if the bottom is 0 in either case. We can apply the distributive law just as we do with algebra. Expand binomial products the same way that we do in algebra, and we should always give our answer in simplest form. Okay, so from algebra we've got special products. So when we have a two terms squared added and squared, we know that we get a squared plus 2ab plus b squared. Now we can actually apply this to surds. So here I've got root 7 plus root 3, so we're going to be using this expansion here. So it's the first term squared. So what's root 7 squared? It's just 7. Then it's plus 2 times a, which a in this case is root 7, times b, which is root 3. So I get root 7 times 3. And then plus b squared, so plus 3 squared. Actually, I might write them in there just so that we know root 3 squared. Okay, so from here, I get square root of 7 squared is 7, plus 2 root 21, then plus the square root of 3 squared is just 3. So we end up with 10 plus 2 root 21, because they're like terms, so we can add them together. Okay, here, I square the first term. So I've got 5 root 2 squared, 5 root 2 squared. Then I subtract, because I've got a minus in the middle, so minus 2 times a, which is 5 root 2, times b, which is root 3. And then I plus root 3 squared. Now, 5 root 2 squared, 5 squared is 25, root 2 squared is 2, so I end up with 50, because I've got 25 times 2. Here, we end up with 2 times 5, which is 10, negative 10. Under the square root, we've got root 2 times root 3, which is root 6. And then I've got plus, and I've got root 3 squared, which we know is just 3. So we get 53 minus 10 root 6. Okay, so we squared the 25. We squared the 5 because we know that when we square 5 we get 25. And because there's a squared outside, it means you have to multiply everything inside. So I get 25 times 2, which is 50. I've got 2 times 5, which is 10. Underneath the square root, I've got 2 times 3, which is root 6. We can't do anything else with this because there's nothing that goes into 6 that's square rootable. Okay, let's have a look at this last one. I'm going to try and do it quickly. So, oops, somehow I changed to purple. Okay, so the first term squared, in this case here, root 3 squared is 3. Then I've got a plus. These two things multiplied together. So I'm going to say 5. I've got to multiply it by 2, because the formula says multiply it by 2. So I've got 2 times 5 root 6 times root 3, which I get as 10 root 18. And then I've got 5 and root 6 squared. So 5 root 6 squared, that's going to be 25 times 6, which I get is 150. Now from here, I get 150 plus 3, which is 153. 10 root 18, I know that 10 is a whole number, we leave that. But underneath, I've got 9 times 2. So I get 153 plus, the square root of 9 is 3, so I get 30 root 2. And that's it in its simplest form, because we can't do anything with that root 2. Okay, so this is without doing your full expansion. You can just use the rule. Okay, here we've got a difference of 2 squares, so that's just a squared, my first term squared. So if we do it by hand, we get root 11 times root 11, which is root 11 squared. Then I would get plus root 55 minus root 55, and then I would get minus root 25, which gives me 11, they cancel, and then I get minus 5, so our answer is 6. However, we want to use the rule. So in this case here, A is root 11, B is root 5. It's just root A squared. It's A squared minus B squared. So here, it's root 11 squared minus root 5 squared. Root 11 squared we know is 11. Root 5 squared is 5. So we just end up with 6. Okay, so that's a difference of 2 squares, and you'll notice every time you have a difference of 2 squares with surds and you multiply them, there'll be no surds left. The surds always disappear. Okay, so here we have a similar problem. That's A, that's B. It's a difference of 2 squares. So first term squared, 2 root 3 squared, minus, because our rule says minus, and then root 4 squared. Okay, if I do 2 squared, I get 4, and if I do root 3 squared, I get 3. 4 3s are 12. The square root of 4 squared is 4, so 12 minus 4 is 8. You can multiply it out the long way, but it's much faster if you know the rules. You don't have to do the working out. And if you go into a higher math, they'd expect you just to be able to do it straight away. So, okay, so we can apply the identities. A plus B all squared is A squared plus 2AB plus B squared. A minus B all squared is A squared minus 2AB plus B squared. A minus B, A plus B is a difference of 2 squared, A squared minus B squared, to calculate problems involving surds. Okay, so now you can have a crack at questions from 2C and 2D in your textbook. And hopefully you understand what you're doing from what I've just explained. Good luck.